The use of cellulose in the reinforcement of cement, a MECH 450D presentation. The construction industry is responsible for 50% of the world's consumption of raw materials and 40% of the world's energy consumption. As society has become more aware of the negative ramifications of statistics such as these, there has been a global push to reuse natural resources and replace toxic synthetic materials with natural ones wherever possible. A new forest bioproduct that is accomplishing both these goals is plant cellulose, which is being used as reinforcement for cement in the construction industry. This presentation will discuss the process from going from tree to bioproduct and the material properties cellulose has to offer, as well as the environmental and economic benefits that come from its use.
The cellulose used in cement and concrete come from the byproducts of the pulp and paper process. Trees are harvested and sent to pulp and paper mills where they produce a finished product, which gives way to waste used in concrete and cement. Or these byproducts come from the pulp and paper recycling process. Through research, it was found that paper-based cellulose fibers used in cement were categorized as being from either waste paper sludge or paper and cardboard waste. The properties of these products varied largely depending on the grade of paper, raw material used, and the processing technique used during pulping, such as craft versus mechanical pulping. Traditionally, these byproducts are disposed of in landfills. Disposing of these byproducts poses negative environmental impacts due to trace contaminants such as ink, dyes, glues, and pigments potentially affecting surrounding soils and bodies of water. By utilizing the biowaste, it reduces the energy and materials needed in cement and concrete, as well as avoiding environmental impact of disposing of these products. Incorporating the cellulose into concrete or cement was found to have been done in various ways. Looking at concrete as a building material, it's considered a mixture of sand, coarse rock or aggregate, water, cement, and other additives, in this case adding cellulose-based materials to the mixture. If you dig into this topic, you'll find complex ways of integrating cellulose into cement at a nanostructure level, or other methods such as just directly adding these bioproducts into cement or the concrete mixture. We've seen waste paper sludge mentioned in class coming from the recycling of pulp and paper in foam during de-inking, or clarifier in biological sludges. Paper and cardboard waste are pretty self-explanatory, as seen in the bottom right of the slides there. These shreds of waste paper are incorporated into the concrete mixture, giving improved material characteristics at specific waste paper amounts per mixture. And it's important to mention that both of these methods of incorporating waste into cement and concrete utilizes paper cellulose to provide increased strength, giving the benefit of using waste and providing more favorable material behavior.
As mentioned, cellulose is a bioproduct that is found in the cell walls of plants. In the wood matrix, cellulose acts as a structural component, providing strength and rigidity, making it an ideal natural additive to cement. A study conducted in 2011 found that the addition of cellulose from recycled paper into cement improved the modulus of rupture, modulus of elasticity, and compressive strength. When tested against a control specimen, the cellulose reinforced cement increased the modulus of rupture from 1.5 to 2.2 megapascals, the modulus of elasticity from 0.5 to 2.5 gigapascals, and increased the cement's compressive strength from 27.5 megapascals up to 37 megapascals. These strengths were achieved from a 5 to 10% addition of paper waste cellulose fibers. However, waste paper cellulose reinforcement greater than 10% saw a decrease in the above-mentioned properties. On top of the improved mechanical and structural properties, the polymer's fibers are also lightweight compared to many synthetic agents that are traditionally used in cement. With the addition of 16% fiber content, the bulk density of cement has been found to decrease from approximately 2,000 kilograms per meter cubed to 1,000 kilograms per meter cubed, making it a desirably lightweight construction material.
Environmental resources are essential for sustaining life on Earth, and utilizing cellulose fibers and cement composites offers several benefits in this regard. Firstly, it contributes significantly to waste management by repurposing waste paper and paper sludge, thereby reducing the volume of waste sent to landfills. This practice aligns with the principles of a circular economy, where materials are reused and recycled, promoting sustainability and reducing the overall environmental footprint. The incorporation of waste paper fibers and cement composites has the potential to conserve energy and decrease CO2 emissions by diminishing the demand for conventional cement materials, which are notorious for their high energy consumption. Additionally, this approach facilitates resource conservation by reducing the reliance on primary raw materials. Overall, the integration of waste paper fibers into cement composites addresses pressing environmental concerns and fosters innovation towards a greener and more resource efficient future. In this economic review, the comparison between cellulose and synthetic cement production is explored. Beginning with the raw materials, cellulose is more affordable option at $857 per megaton compared to $40 per ton of limestone, which is a key component in synthetic cement. This clear difference highlights the cost advantage of cellulose. However, it is also important to note that the price of cellulose actively fluctuates, as seen in this graph. As mentioned in the previous slide, cellulose fiber cement produces less energy and CO2 emissions compared to synthetic cement, which can lead to tax savings. This also implies long-term savings as less energy will be required, which is typically sourced from coal and petcoke combustion. Additionally, the increased strength of cellulose fibers may reduce the need for additional materials. While precise cost breakdown for cellulose fiber cement production are unavailable at this time, the notably lower price of cellulose and the prospect of energy and emission savings presents a clear economic argument for its adoption over synthetic cement.
Thank you for listening to our video. Please let us know if you have any questions.